Hello! Today in the lesson we will solve examples in which we will add or subtract like terms. Let's write down the following example. 2a minus 8, a plus 9b, 5b plus 3a. In this example we can see that the terms have a letter part that equals a. And there are terms that have a letter part that equals b. In order to solve this example correctly, let's find similar terms. Again, like terms are terms that have the same letter part. Only the quotient differs. In order to make sure, to avoid getting confused by like terms, I recommend underlining like terms with the same lines. I see 2a's minus 8a's and 3a's, and I underline these terms with the same line. Why? So that when I rewrite this example, and to write them side by side, I write down 2a's, minus 8a's and plus 3a's. Notice that we write each number with its sign. The sign of the number is written in front of this expression. I wrote down 2a's, then minus 8a's and plus 3a's. Each like term I write down with its sign. And I have 9b's left. And minus 5b's. Notice I've marked these two like terms with a squiggly line. And now I'm going to write them down. And I'm going to write them down with my own signs. So that you don't get confused about which sign. You write down the sign that goes with that number. 9b's with a plus sign. So I'm writing plus 9b's. And that's very important when you're solving examples like this. Then there is a number minus 5b, I write minus 5b. Pay attention to the sign that is written before the number, and this will be its sign, and then you will not make mistakes in the sign. Now what can we do? 2a minus 8a plus 3a. These summands can be added together. 2a minus 8a is minus 6a. And plus 3a would be minus 3a. 2a's minus 8a's minus 6a's. Minus 6 plus 3a's is minus 3a's. Performing the action where the letter part equals b. 9b's plus 9b's minus 5b's would result in 4b's. I say 4b's, I don't say minus 4b's. If I say 4b's, it's positive. Then I put a plus sign. The result is minus 3a's plus 4b's. Minus 3a's and plus 4b's are not like terms. I cannot perform actions with them, so this will be the answer. I want to pay attention to performing the actions. If you find it difficult to count 2a minus 8a and plus 3a, you can write this action in another form. You can write a in front of the parenthesis and then write the quotient in the parenthesis. 2 minus 8 and plus 3. And calculate what that equals. 2 minus 8 is minus 6. Minus 6 plus 3 is minus 3a. The result is minus 3a's. Please note that when you write down algebraic expressions or letter expressions in math, it is customary that you write down the quotient, the number, and then the letter part. Next, if I were to work the following syllables, plus 9b's and minus 5b's, I can write down the b's. And then in parentheses count 9 minus 5. Work with the quotient and I end up with 4b's. As you can see, the answer is the same. Let's solve another example. 3t's minus 3u's minus 2t's and minus 2u. Before we convert this expression, let's find like terms. And we see 3t's minus 2t's. Let's write down 3t minus 2t's minus 3, u minus 2u. Notice how I'm writing it down. Minus 3, u minus 3, u minus 3, u minus 2u. Now let's do the math. 3t's minus 2t's is 1t, and minus 3u minus 2u's is minus 5u's. The result is 1t minus 5u's. One more remark. In math, it's customary not to write down the quotient of 1. So I can write this expression as t minus 5u. And one more example. Since we paid attention to the coefficient equal to 1 in the previous example, we will solve this example. X minus y plus x minus y minus 2x minus y. In this example, I'm going to find similar summands first. Plus x minus 2x's. So we'll write down x plus x and minus 2h. And now we'll write minus y plus y and minus y. Minus u plus u and minus y. In order to count correctly, we will remember that if no number is written in front of the letter part, the quotient is equal to 1. In order to make it easy to do the math, we'll put 1. And then 1x plus 1x is 2x's. 2x minus 2x's is 0h. Let's find the sum of y. Minus y plus y is also minus 1 plus 1. That's 0. 0 minus 1 is minus 1y. As you can see, we have one summand, 0x's. But we know that if I multiply 0 by any number, I get 0. So the answer is minus 1, because that summand will equal 0. By applying the rules of addition of like summands, we've solved these examples. Next lesson, we'll solve some more examples. And that's all for today. Goodbye, see you again.